Hello. In this video I'm going to show you how to solve the indefinite integral of 1 over a plus cosine of x, where a is some real number. We're going to use the so-called Weierstrass substitution, in which we let u be equal to the tangent of x over 2. Then our goal is to be able to express cosine of x and dx in terms of u and du. We're going to start with the double angle identity for cosine. So cosine of 2x can be written as 1 minus 2 times sine squared of x. Then we can write that this is equal to 1 minus 2 times tangent squared of x times cosine squared of x, since tangent of x is just sine of x over cosine of x. Then we can write that this is equal to 1 minus 2 times tangent squared of x over 1 over cosine squared of x, since multiplying by cosine squared of x is the same as dividing by its reciprocal 1 over cosine squared of x. Then this here is equal to 1 minus 2 times tangent squared of x over, and we're going to write 1 as sine squared of x plus cosine squared of x, the famous trigonometric identity, and is divided by cosine squared of x. Then this here is equal to 1 minus 2 times tangent squared of x over, first we're gonna write cosine squared of x divided by cosine squared of x, which is 1, and plus sine squared of x over cosine squared of x, which is tangent squared of x. And then we're gonna get the 1 to the numerator by multiplying with the 1 plus tangent squared of x, and from that we're gonna subtract the 2 times tangent squared of x, and all of this divided by 1 plus tangent squared of x, and this is equal to 1 minus tangent squared of x over 1 plus tangent squared of x. This here then implies that cosine of x, which we can write as cosine of 2 times x over 2, is equal to 1 minus tangent squared of x over 2 divided by 1 plus tangent squared of x over 2. And since we said that u is equal to tangent of x over 2, we get that cosine of x is equal to 1 minus u squared over 1 plus u squared. And let's put this result also up here. Cosine of x is 1 minus u squared over 1 plus u squared, and next we're gonna tackle the dx. First, we note that du over dx is equal to 1/2 times 1 over cosine squared of x over 2, since the derivative of tangent of x would be 1 over cosine squared of x, and we have the inner function x over 2 whose derivative is just 1/2. Then this is equal to 1/2 times sine squared of x over 2 plus cosine squared of x over 2 divided by cosine squared of x over 2, so we use the same trick as we did with the cosine part. So this is equal to 1/2 times tangent squared of x over 2 plus 1, which is equal 1/2 times u squared plus 1, and this then implies that dx is equal to the reciprocal of that times du, so 2 over u squared plus 1 du. And let's put this result up here as well. Dx is equal to 2 over u squared plus 1 du. And now we're ready to tackle our integral. I is equal to the indefinite integral of 1 over a plus 1 minus u squared over 1 plus u squared, and all of this times 2 over u squared plus 1 du. Then let's take the 2 to the front and multiply the denominator by u squared plus 1 to get 2 times the indefinite integral of du over au squared plus a plus 1 minus u squared. And this is then equal to 2 times the indefinite integral of du over a minus 1 times u squared plus a plus 1. Then, to be able to integrate this, we're gonna do the following trick. We're gonna take the a plus 1 to the front and get that is equal to 2 over a plus 1 times the indefinite integral of du over the square root of a minus 1 over a plus 1 times u all squared plus 1. Then we're going to make the following substitution. Let t be equal to the square root of a minus 1 over a plus 1 times u, so that dt is equal to the square root of a minus 1 over a plus 1 du, which then implies that du itself is equal to the square root of a plus 1 over a minus 1 dt, which then means that we can write that our integral I is equal to 2 over a plus 1 times the square root of a plus 1 over a minus 1 times the indefinite integral of dt over t squared plus 1. And this integral here is a known integral, it's the arctangent of t. And then we're going to also simplify the product in front by taking the a plus 1 inside the square root, so we can cancel the a plus 1 from the numerator. In the denominator we're left with a plus 1 times a minus 1, which is a squared minus 1. So we're going to get it's equal to 2 over the square root of a squared minus 1 times the arctangent of t plus some integration constant c, and then we're gonna go back to our original variable x to get that our integral I is equal to 2 over the square root of a squared minus 1 times the arctangent of t was equal to the square root of a minus 1 over a plus 1 times u, and u itself was equal to tangent of x over 2, so we're gonna get square root of a minus 1 over a plus 1 times tangent of x over 2 plus our integration constant c, and this here is our final result.